Hi everyone, welcome to the video series on computer simulation technology, Microwave Studio. In the last lecture, we have covered a periodic structure template, but in this video, I want to show how we can create a structure and how we can set up our simulation and optical application. So click optical application and click next. So here you will see two workflow: plasmonic metallic structure, dielectric structure. Plasmonic metallic structure, actually, if your design structure includes some metal layer, so you can select plasmonic structure. Otherwise, if your structure include a dielectric substrate, so you select dielectric. Like if you are working on a lenses, so you just select a dielectric structure. But I want to design nano antenna, so it includes some metal layer, and that's why I selected here. Again, a different workflow: nano antenna, plasmonic waveguide, plasmonic solar cell. So I select nano antenna. If you are working on a plasmonic waveguide devices or a solar cell application, you can select it from here. I select a nano antenna. Uh, Here, frequency domain and time domain. As I explained in the last video, the difference between frequency domain and time domain. So I just select the frequency domain for my simulation. Okay, here I will select a dimension like this time the dimension will be in micrometer. Last time I was use millimeter range. Okay, micrometer and frequency is in terahertz. So click on next. Here you can select a wavelength or frequency. Anyone you can select. Like if you are working on a solar cell application, so solar cell actually work in a visible region. Visible region is from 3 micrometer to 7 or 7.5 or even 8 micrometer. You can select like this. But I want to design nano antenna, and I select the range for the range of frequency for nano antenna is from 1 to 700 terahertz. You can select electric field, magnetic field also. Select all of them, and similarly you can go with a default step size, or you can define it from your own side, just like I have created this uh, frequency step size table for my simulation. This is 1 2 step size, and this is a step size and a point. Like I can select like this. Okay, I can select like this small step size. As I also told you that if your step size is small, it means CST will give you more accurate result in your simulation. Okay, click on next. Here, this template show that what you have selected for your structure, like the solver, the unit, the setting. Okay, click on finish. So you will finally come to the interface where you can model, you can simulate, you can find any result of your design structure. Okay, in last lecture I explained how we can create a geometry. Simple geometry I was created, but in today video I will show you one basic geometry. Okay, click on model, select break here, and here we can first put some parameter uh, mm, like a. So I'm going in a -6 direction, so it will be -a, and minus b. Sim sorry, a. X-axis is a, and y-axis is b. Okay, and then z-axis I keep z 0 because I don't want to go in the negative z direction. I just keep the thickness of my substrate in a positive z direction, so I keep t is for thickness, and I load a material from here. Okay, any material you can load, so I load polyimide lossy substrate. Okay, and then click on preview. Here you can give value to your parameter, what you have selected for your structure. Like for A, I have put 3.8. Okay, if I want to create square type substrate, so I will uh, put the same value for A and B. okay, and then thickness will be 1 micrometer of my substrate. So you have you will create substrate in this way for your structure, okay. So this color is not more visible. I will change the color from here. Right click here, so change color to blue. Blue is more visible, okay. And see the front face of your structure. So I want to draw some resonator on the front face of this substrate. So I select this pick, okay, click on pick and then double click the red one and right click. So select set WCS value, align WCS and select it face, okay. In this way you can design something on your on the face of the substrate. Okay, I want to draw a ring. Uh, Here I put value R out, okay, outer radius and inner radius for R in, and then I keep the U and V center 0, 0 because I want to draw on the center of this coordinate system. I just put here T R. So T is the thickness, R is the para resonator, okay, and I select here some metal from here like silver, okay. I select silver and click on preview. So R out will be, I put for R out 3 4, okay, and for R inner I put 3 micrometer and the thickness 0.035 micrometer thickness of the metal layer. So you see that you have created structure like this, but the ring is outside from my substrate. So how can I decrease the radius? Okay, so the advantage of this parameter is you can change the value. First I change the R inner to 2.5, okay, click enter and then press F7 from the keyboard, okay, and then decrease this radius or outer to 3.5, okay, and press F7 from your keyboard. You will see uh, this the ring radius is changed, okay. In this way you can change, you can increase, you can decrease the value of the parameter you have placed for your structure, okay. Now remove this axis. So click on the WCS, local WCS here. So uh, I want to design a perfect observer, like perfect observer in China. So in this case, the transmission for my design structure will be 0. So I just put the metal layer at the back side and completely cover the back side of the substrate. Okay, so select back from here and then click again back. Okay, double click and then right click. So this way you can select again axis. Uh, so here I press break, plus minus A. Okay, if the same value is I have put for the substrate because I want to cover the back side completely of my structure. A here again A, okay, minus B and B. The thickness I keep the thickness of the metal layer same, like I have uh, enter the thickness for the ring TR, and the same I place here. TR is thickness for the back side layer, metal layer. Click preview and then click OK, and then click local WCS, remove the excess. So in this way you can design a perfect absorber, a ring type, okay. uh, so next video I will show you how we can uh, select the boundary condition for our structure, and how we can run the simulation, and how we can use different operator for our simulation, okay. So thank you for watching. See you in the next lecture.